Hello, dear students. Today we are going to see the chapter Polynomials. Yeah, dear children, what is a polynomial? I'm very sure that you already know that. It's not a new concept. Yeah, what is a polynomial? Yeah, polynomial is an algebraic expression. All of you know that. Polynomial is an algebraic expression. Yeah, we can write some examples of algebraic expression. 4x square minus 3. 2x raised to 4 plus 3x minus 10. Y square minus 10. Yeah, these are algebraic expressions. Then one more I'm writing. X raised to 1 by 2. X raised to 1 by 2. Let it be there. Okay. These are algebraic expressions. Okay, very sure that these all are algebraic expressions. But among these, which of them are polynomials? To identify that, you must know what is a polynomial. Is it, dear children? Yeah, first one is a polynomial. Second one also a polynomial. Third one also a polynomial. But the fourth one is not a polynomial. Why? Yeah, here x, y, x are used. That's why. Can you identify? Can you tell why last one is not a polynomial? Yeah, dear children, the first important thing is in a polynomial, the power of the variable is a whole number. It should be a whole number. Power of the variable should be a whole number. Yes, here, which is the variable? X. What is the power of x? 2. 2 is a whole number. So, 4x square minus 3 is a polynomial. In the second one, 2x raised to 4 plus 3x minus 10. In 2x raised to 4, power of x is 4. It is a whole number. In 3x, power of x is what? What the power of x in 3x? 1. If we wrote or not, yeah, that is 1. Then power of x is 1. That is also a whole number. In y square minus 10, what is the power of y square? It is 2. It is also a whole number. That is why these first three are polynomials. But in the last case, in x raised to 1 by 2, check it. What is the power of x? It is 1 by 2. Is it a whole number? No. That is why x raised to 1 by 2 is not a polynomial. Okay, dear children. I think all of you understood the definition of polynomial. Polynomial. What is a polynomial? Polynomial is an algebraic expression with whole number as the power of the variable. Right all. Yeah, write the heading. Polynomials. Write the chapter name. Chapter name is Polynomials. And write the subheading Polynomials. Write the a polynomial is an algebraic expression. A polynomial is an algebraic expression with whole number as the power of the variables. A polynomial is an algebraic expression with whole number as the power of the variable. Then example. Yes. Examples. Yeah. 3x raised to 5 minus 6x. 3x raised to 5 minus 6x. 2y minus 1. 3x raised to 5 minus 6x. 2y minus 1. Next one. 3y raised to 9 plus 2y square minus 11. Nothing more, dear children. Yeah, it should be an algebraic expression. Expression means a variable, a number, and number operations, mathematical operations, and the power should be positive. Positive integer or whole numbers. It should not be negative or fraction. That much only. Yeah. Then next. Yeah, why we are using x and y? You can use any variables, but most commonly x and y using. That's why. 3z whole raised to 6 plus 6z raised to 2. It is also an algebraic expression with a positive integer as the exponent or power of the variable. So that one also a polynomial. Yes. Let me ask. Is 1 by 2x a polynomial? Is 1 by 2x a polynomial? Or root 2x a polynomial? Or root 3y square a polynomial? Yeah, these all are examples of polynomials because we have to check the exponents or power of the variable only. Here x, what's the power? 1. But yeah, power is a positive number. So it is a polynomial. Here also power 1. So it's a polynomial. Here power 2. Then this 1 by 2 or root 2 or root 3. It is not affecting the power of the variable. So these all are examples of polynomials. You can write it. Yeah, write that also, dear children. Examples. 1 by 2x, root 2x, root 3y square. This root symbol only for 2 and 3, not for this x and y, dear children, while writing root 2x. Then root 3y square. X and Y are not inside of root symbol while writing. Yeah, dear children. Okay. Next, tell me some examples of algebraic expressions which are not polynomials. Right. Next. Not polynomials. Yeah. X raised to negative 1 plus 3x. Here, the power exponent of the variable x is minus 1. It is not a whole number, not a positive number. So, it is not a polynomial. Next, y raised to minus 4 plus y plus 10. Yeah, here also the variable's power is minus 4, not a positive number. So, it is not a polynomial. One more example. Yes. While writing that examples of polynomial, I told that don't write x inside of the root symbol. Why? Here root x. What is the power of x in root x? Is it a whole number or is it a positive integer? Yeah, dear children, root x, its value is x raised to 1 by 2. Root x equal to x raised to 1 by 2. Very important concept. Root x equal to x raised to 1 by 2. Yeah, here the power of x is 1 by 2. 1 by 2 is not a whole number. So, what we can tell, x raised to 1 by 2 is not a polynomial. If x raised to 1 by 2 is not a polynomial, then yeah, root x is not a polynomial. The question asked to write examples of algebraic expression that are not polynomials, you can write root x or root y. Any variables you can use. Okay. Yeah, dear children. I think all of you understood what is a polynomial, and you can easily write the examples of polynomials and an algebraic expressions which are not polynomials. Okay. Now we are going to study different concepts related to polynomials. First one. Terms. Terms of the polynomial. Terms. Yeah, dear children, while writing the examples of a polynomial algebraic expression that are not polynomial, you can write a root x, root y like that. Next, terms. I think in 8th standard you've already studied plus symbol determines the terms of the algebraic expressions. Plus symbol. Then 2x plus 3. How many terms are there? What are the terms of 2x plus 3? Plus symbol determines the terms. So, plus, you can say this plus symbols, divides into two parts. One is 2x, one is 3. So, this 2x plus 3 contains two terms. One is 2x and another one is 3. Only two terms there. One is 2x and the second one is 3. Okay, dear children, all of you write terms and write below that. Terms of 2x plus 3 are terms of 2x plus 3 are 2x and 3. Terms of 2x plus 3 are 2x and 3. 2x and 3. Then second, terms of 3y square minus 6y plus 2. Terms of 3y square minus 6y plus 2. Yeah, what are the terms? I've already told that plus symbol determines the terms. Here a plus symbol, but one plus symbol you can see. Then here, what about this one, dear children? This minus symbol. Yeah, we can rewrite this as 3y square plus minus 6y plus 2. 3y square plus minus 6y plus 2. Plus into minus becomes this minus. So, 3y square plus 6y plus 2 contains three terms. What are the terms? 3y square minus 6y and 2. Write the terms of 3y square minus 6y plus 2. Below that, 3y square minus 6y plus 2 equal to 3y square plus minus 6y plus 2. Plus minus 6y plus 2. Okay, then is terms are 3y square minus 6y 2. Terms are 3y square minus 6y then 2. Okay, next. Terms of third example. Terms of 1 by 2x square plus 3x minus 1. Terms of 1 by 2x square plus 3x minus 1. Yes, same way. What are the terms? 1 by 2x square. Okay. 3x. Then, is it 1? No, dear children. This 1 we can rewrite as plus minus 1. So, the terms are 1 by 2x square, 3x and minus 1. Okay. Yeah. I think all of you understood the terms. Next, coefficients. Yeah. Listen, dear children, before starting coefficients, what is the factors of 2? A factor of a term. 2x. What are the factors? Yeah, factors means, for example, the number 8. What are the factors of 8? 1, 2, 4, 8. That means 1 into 8, 8. 2 into 4, 8. So 1, 8, 2, 4 are the factors. That means when we multiply the factors, you will get the given number. Or we can write the given number as the product of the factors. So 2x, how can we write? Yeah, very simple. 2 into x. 2 into x. So the factors of 2x are 2 and x. 1 into 2x, that like that also. So 2x, 2 and x. Here in 2x there are two factors, 2 and x. Then which is the numerical factor? Numerical factor is 2. So the numerical factor is known as the coefficient of the term. Numerical factor. Here 2 is the coefficient. 2 is the coefficient. Okay, the next example, 5x square, which is the numerical factor. Okay, 5 is the numerical factor. So 5 is the coefficient of that term 5x square. Okay. Yes, write the heading coefficient. Coefficients. Okay. The numerical factor of the term. The numerical factor of the term. Are you writing, dear children? Right. Coefficients. Heading. Then write. The numerical factor of the term is called coefficients. The numerical factor of the term is called coefficients. The numerical term is called coefficients. Yes. Yes, right. Write the coefficients of the terms of 5x square minus 3x plus 10. Coefficients. You can write example 1, 5x square minus 3x plus 10. Below that, coefficients of 5x square equal to, tell me, what is the coefficient? 5. Coefficient of 5x square equal to 5. Then write below that, coefficient of minus 3x equal to, yeah dear children, why minus comes? Plus minus 3x. Coefficient of minus 3x equal to minus 3. Yes. Then let me ask, what is the coefficient of 10? That is 10 is also a term. What is the coefficient? Yeah, 10 is the coefficient because it contains only numerical factor 10. Coefficient of 10 equal to 10. Okay. That 10, why means actually 10 we can write as 10x raised to 0. If you need, in the bracket you write 10 equal to 10x raised to 0. Why? What is the value of x raised to 0? 1. 10 means 10 into 1. Okay, instead of 1 you can write x raised to 0. Then coefficient of 10x raised to 0 is same as coefficient of 10 equal to 10. Next, second example, 1 by 2 y cube plus 6y. 1 by 2 y cube plus 6y. Below that, right? Coefficient of 1 by 2 y cube equal to, coefficient of 1 by 2 y cube equal to 1 by 2. Then coefficient of 6y equal to 6. Okay. I think all of you understood that one. Yes. Terms, coefficients. Next time. Yeah. We already defined what is a polynomial and examples of polynomials. Okay. Next. Let me ask that. Is number 2 is a polynomial? Is number 2 a polynomial, dear children? Yeah, in the last example, yes, we can rewrite 10 equal to 10x raised to 0. Same way, 2 equal to 2x raised to 0. Because x raised to 0 means its value is 1. Last year you've already studied in laws of exponents. A raised to 0 equal to 1. Same way. Then number 3, if I am using another variable y, then 3 is same as 3y raised to 0. Is it? Then next 10 x raised to 0. Hundreds z raised to 0. We can write every number like that. Minus 3 x raised to 0. Then these all the numbers are polynomials. These all the numbers are known as polynomials. Is it? Then these numbers, yeah, listen dear children, these numbers are constants. You already know that, constant numbers. So these are known as constant polynomials. Right? Constant polynomials. Write the heading, constant polynomials. Constant polynomials. Yeah, below there write the 2 equal to 2x raised to 0. That means we already know the condition of polynomial means exponent should be a whole number. Is 0 a whole number? Yeah. So 2 equal to 2x raised to 0 a polynomial. Then 10 y raised to 0. 50 y raised to 0. Write this out. 2 equal to 2x raised to 0. 10 equal to 10y raised to 0. 50 equal to 50y raised to 0. Yeah, below that, the numbers 2, 3, 4, etc. Numbers, any number. Numbers are constant polynomials. Are constant polynomials. Constant polynomials. Yeah, next. Yes, what about 0? Is 0 a constant polynomial? Can we write 0 as 0 into x raised to 0? Why not? Not only that one, 0 is x raised to 1. 0 into any number means 0 is 0 we can write in any way. So 0 is also a polynomial. So we can call 0 as a 0 polynomial. Write the heading 0 polynomial. 0 polynomial. 0 polynomial. Yes, write the constant 0 is called 0 polynomial. 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 Okay, you can write 0 equal to 0x raised to 0 or 0 equal to 0y raised to 0 equal to 0x raised to 0 or 0 equal to 0y raised to 1. Any one, because 0 into any equal to 0. That is why 0 polynomial. Next, okay, these are the main concepts you have to understand. One more concept is there. After that only we can move to problems. Okay, next, degree of the polynomial. Next heading, degree of the polynomial. Degree of the polynomials. Degree of the polynomial, sorry. Degree of the polynomial. Okay. Degree means, yeah, let me explain. Here, one polynomial, 2x square plus 5x raised to 6 plus 1. Yeah, very sure that's a polynomial. Then in 2x square plus 5x raised to 6 plus 1, first term 2x square, second term 5x raised to 6, third term 1. What is the power of x into x square? What is the power? 2. In 5x raised to 6, what is the power? 6. Here 0. When I am not writing. 1x raised to 0. Which is the highest power? 6. So 6 is the degree of this polynomial. 6 is the degree of the polynomial. So right there, the highest power of the variable is called, the highest power of the variable is called degree of the polynomial. The highest power of the variable is called degree of the polynomial. Example 1. Degree of the polynomial is, right, example 1. Yeah, right one. 2x raised to 6 plus 3x raised to 4 plus 10. Then right below that, degree of the polynomial equal to, degree of the polynomial equal to, what is? Equal to 6. All understood why 6? 2 powers here 6 and 4. Highest one is 6. So degree of the polynomial equal to 6. Then next one. Second one. Second example. 5x raised to 100 plus 3x minus 6. 5x raised to 100 plus 3x minus 6. Then write the degree of the polynomial equal to, degree of the polynomial equal to what? 100. Degree of the polynomial equal to 100. Okay. All of you understood why it is 100? 100 and here 1. Greater 1. 100. I think all of you understood this degree of the polynomial. While writing more problem, you will understand more. Next, let me ask, what is the degree of a constant polynomial? Oh, yes, 2 is a polynomial. Yeah, what is the degree? Yeah, 2 equal to 2x raised to 0. So, the degree of the polynomial equal to 0. Then 10. 10 y raised to 0. Degree of the polynomial equal to 0. Yeah, below that you write degree of the constant polynomial. Degree of the constant polynomial. Degree of the constant polynomial. Yes, right there. 2 equal to, right, 2 equal to 2x raised to 0. 10 equal to 10 y raised to 0. Repeatedly we are writing, so no need of more example, right? Degree of the constant polynomial equal to 0. Degree of the constant polynomial equal to 0. Degree of the constant polynomial equal to 0. Okay. Next, degree of 0 polynomial. Write the heading, degree of zero polynomial. Degree of zero polynomial. Tell me. 0. Can I write 0 equals 0 x raised to 0? Can I write 0 equal to 0 x raised to 1? Can I write 0 equal to 0 x raised to 10? Or 0 x raised to 55? Here 0 is the degree. Here 1. Here 10. Here 55. So, can we tell which is the? No. Different way we can write. So, we can't tell which one is the degree. In first case 0 is the degree. In the second case 1. Third case 10. Fourth case 55. So, we can tell degree of the 0 polynomial is not defined. Right there, degree of the 0 polynomial is not defined. Degree of the 0 polynomial is not defined. Okay, dear children. I think all of you understood all the concept we discussed here. Okay.